Welcome everybody. We'll start today's lecture. This is lecture 3 in week 2. And we're going to look at some of the fundamentals of software development with C#. I'm sure some of you have looked at the tutorial already. But I want to bring your attention to just a few interesting pieces. I mean, you know how to program already. Okay, that's a given the fact that you're third year. You know how to do W02 programming already because you've done Java for a couple of years now. And I mean, you're in third year, right? So it shouldn't be too difficult. But there are always nuances associated with learning any new language, and I'll just take you through a couple of them that would be useful. I noticed that in the past that people tend not to use or deal or work with enumerations. Okay, have you come across enumerations? Yeah? No? There are ordinal types. Do you know what an ordinal type is? No? Right. So, okay, so let me figure this one out then. Go back. Okay, if I give you the number 3.17, what comes next? Well, could be anything, right? Whatever you choose, I can always choose a number that's between the number you choose and 3.17, yeah? See the difficulty with that? Okay. If I give you the number 7, what comes next? It's not a trick question. Okay, it was a trick question. Okay, it could be 10, right? Okay, if I was, you knew, you should have said, okay? Right, but the point is that it's deterministic, okay? And so we know that with some ordinal types or something, we know where it is in the list of all of the set, the full set of all those numbers, yeah? That make sense? So it's very useful for us sometimes where we have a limited list of things to give them a name. So we might have a bunch of colors that are available to us. And so instead of setting up a constant that you can't change with a color, for example, saying color black is 0, but color white is 1, color red is 3, and we don't need any more colors, right? So it's useful to be able to have that kind of notation built into a language, okay? And they're often called enumerations, okay? And we can set them up as sets, and we can manipulate them in just the same way as you do sets. And I know all third-year students, computer science, love mathematics and set theory. So all of the stuff you know about set theory can work with these enumerations as well. So it's useful, right? So I want to tell you a little bit about iteration as well. And I want to tell you a little bit today about objects. And the next lecture, which will be online tomorrow, we'll go into these in a little bit more detail. Remember, guys, labs start today. Okay, so you need to be attending labs. If you can't attend a lab, I'll have to have an exceptional circumstances reason. I mean, I know people are, you know, you're third years now and you're applying for interviews, and sometimes they overlap with labs, and I understand this, and we can always make arrangements for you to do separate lab or different lab in those circumstances. If you're sick, you get sick. That happens as well, of course. We need doctor certs, that would be fine. And you know, there may be something else going on in your life that you need to talk to me about, and that's fine too. So, but you do need to get to labs. And every single lab that you attend, there will be contribution from that lab, and from the demonstration that you give on your current assignment in that lab is worth about 10% of your total continual assessment for the current assignment. So be there, be present, show the demonstrator what you're doing, ask questions. You know, some people will progress more than others, you know, and that's fine too. But show that you're working on something and you understand something, and that's all they'll ask. And they'll spend about 5 minutes with you. In every single lab, they'll get to know you, get to know what the progress is, and so forth. Okay? And it's a useful exercise for you, and it's a useful exercise for us as well to see how things are going. Okay? You do need to get to them. There's a tutorial today as well. You need to get to the tutorial. Mark will give a more in-depth overview of C# today as well in this one, and he will talk a little bit about how to do some stuff that will be useful for your assignment. He won't give you an answer to the assignment. We don't do that. I mean, what's the point in giving you an assignment and then asking you to do it and then giving you a solution? We never do this, okay, in this module. So that should happen today as well. I know that people had difficulties getting to, and wrote to me about the problems not getting to the preferred lab. Lots of people want to get into the earlier lab for lots and lots of reasons. Well, one of the reasons that was cited not being in the later lab was because many of you have to get buses from Maynooth. Okay, and that's a problem. And so I went to the bus companies, and I also went to the admissions office who arranged the buses for Maynooth, and they have requested, well, they've more than requested, they've said that no bus should leave before 6:15 now. So many students getting buses to and from Maynooth, no bus should leave before 6:15. Okay, these are contracted by the university, and it doesn't matter what the online table says, they should be changed soon to reflect this, but you know, you shouldn't be penalized. And you can leave your lab at 5 to 6 if you're in the later one, and it should give you 20 minutes to get to any bus on campus, and that should be fine. Okay, so I mean, I can't do anything about trains, but like we can do something about buses. So if you find that these buses are leaving early, tell me, and I'll get back to the person who directly liaises with the bus companies. Okay, so you know, if you encounter these kind of problems and you think that we can help in some way, just say please. You know, I mean, I want you to be able to get to the lab and not be stressed about being in that lab, you know, because I've got to leave or something. Okay, okay, right. Any questions before I get on to the main part of the class? Yes? Tutorial is 3 o'clock. Okay, and in the Auxilia AIX building. Okay. Any others? Yes? I might do it at the end, yeah. I'll pull it up at the end, that's no problem. I can talk about it. And if you have specific questions, you can do that. Yeah, no problem. Anyone else? That question, sorry, in case you didn't hear, was would I be able to talk with the assignment? And I'll do that at the end of the class. Yes, yourself. Yeah, every week, okay. Yes? All is downstairs, okay. The labs, yes? Tutorials are in AIX, which is an Auxilia. And if you go to your timetable online, it actually gives you a timetable and a listing of where everything is, and it also gives you a map showing you where those are, okay? Okay, so it's a good idea to use that timetable to jump off. Not that I don't mind answering the questions, okay, but it's there. Any others? Good, okay, that's good. Right, so one of the things that I want you to start thinking about now as well as third year students is just like earlier on I started talking to you about enumerations, okay? And I use the term enumeration because that's the term that we use, okay? You may have ways of doing this already and know other ways of doing this, but you know, it's really important when learning new languages that you actually use the correct terminology for talking about the languages. Okay? So we talk about identifiers. So some people talk about names, you know, or variable names or something like this. Well, actually start thinking in terms of them being identifiers, right? Because this allows you to move from one language to another language to another language, okay? Because you often get asked in interviews, they use the correct terminology, and many of you will be going to interviews now. So start thinking about using the correct terms, you know, for these things, okay? So you need to be able to use these identifiers, which is a way to name a class, a variable, or a function, or any other user-defined item in a C# application. Now, I mean, you know this stuff from first year. It's the same as your Java, but really I want you to start thinking about using the terms. And the whole point of having this slide here is to get you thinking about using the correct terms, okay, and understanding those terms. So identifiers have to begin with a letter, could be followed by a sequence of letters or digits or an underscore. You can't contain any embedded spaces or symbols, such as the list. Underscores can be used, and identifiers can't be a keyword. Now, it's really important as well that you look at trying to find some naming convention for your identifiers. So there are ways to name variables. There are ways to name classes. There are ways to name functions, methods that are convention, so that you can look at something and you say, oh yeah, that's in my code with hundreds of thousands of lines of code. I know that's a method, or I know that's a variable, or I know that's a constant, or something, okay? So start thinking about looking at conventions and using those appropriately, because that means when you work now as developers, you won't be solo developers. You will be working in teams of developers. So the reason we want you to know and understand the nomenclature, the language that's used, and how we use conventions is so that you can work with teammates on the same code. Okay? And it makes it a lot easier for you. It makes it a lot easier for the team. It helps, with migration, it helps over time, it helps with maintenance, all of these good things. So we're trying to get you to start thinking about best practice in coding now in this module. So we're talking about get you, instead of writing code, designing code that you then write, okay? We want you now not just to be coders, bedroom coders, we want you to be software engineers, okay? And there's the difference. Okay? You need to start thinking about being software engineers, and you need to start thinking about how do I become a software engineer? And that's a lot of it is discipline. You need to be very disciplined with yourself. Okay? Sometimes you go into a company, they'll give you the conventions. They'll say, this is the way we do things here. This is how we name stuff. Okay? Start looking, maybe, do some kind of Google search on naming conventions for C#. I did tell you a little bit about this when we did CS230, but there are ways to do that. There are ways for C# as well. So C will differ from Java. It'll differ from JavaScript, which is very loosely typed. A lot of the time, the type of a variable, for example, in JavaScript will change depending on where it's being used. Okay? A little bit stricter here. And so we have ints and longs, and they're integers. We have doubles and floats. We have chars. We have bools. That is true or false. And these are identifiers. Okay? And all value types and variables have ranges and default values. And you can check how big a number you can save with the size of function. And it's important to know this kind of information when you're looking at computation accuracy. Okay? So, I don't know if you were interested in physics or space, and you saw last night, the dart hit the asteroid from NASA. Exciting stuff. This rocket, missile, device, whatever you want to call it, been traveling for a very, very long time, needed to be precise, okay, really precise. You can be sure that, all of the mathematics around that targeting weren't done with ints or longs, okay? They're highly precise floating point numbers with lots of decimal places of accuracy. Okay? So depending on the kind of work you want to be able to do, you have to know about the precision. I mean, if you're doing some data science, then it matters as well. And if you're just going to be doing something that deals with whole numbers, smaller switching or something, then booleans are fine. But you may or may not be working on applications that are data intensive, but if you do, the choice of these things actually matters. Lots of banking applications still use COBOL. You heard of COBOL? Okay, really cool programming language. I taught it 30 years ago. Okay, I used to teach it to second years, and really interesting language. There's no recursion in COBOL. Okay, no recursion at all. So I used to ask the students to implement a quicksort for me. Okay, which relies on recursion. It's quite hard to do this. But the numerical computations precision is amazing, because fractions of a percent, make a huge difference in financial applications, for example. That's why we use COBOL for this. We might not use C# for that application. And it's the same with Fortran. You've heard of Fortran? Okay, Fortran's a scientific computation language, round about, invented and maybe stopped being used, before many of you were born, but it's still used in a lot of mathematical models for predicting weather, circulation models. Okay? So this whole notion of precision actually matters. You'll notice that sometimes I have this demo up at the top. I think I've said this before, so that means that there must be some demo somewhere in the files that I give you that tell you how to work with this. Okay, so here's a very simple program, and again, what I've done is I'm using the system library, because that system library allows me to be able to access all of the functions that I want to be able to write to the screen and so forth. I'm creating this namespace called demos, which gives me the space and constraints, and it means it allows that when I have and define variables, functions, methods within this namespace, it means that I can have multiple namespaces and repeat or reuse those. Okay? So it locates the variable names within a particular namespace. You don't have to have it. Okay, I could take this out and it worked just fine. Okay, and most of the applications you write, you won't need to actually set up this namespace. But you might need to if you were using an external library that had the same variable names or same method names that you have, and then you might need to be able to define or locate the correct one to use by referencing it using the namespace. We have our public static void, so I'm creating some value types here, and it'll tell me the size of these ends. So we can run this and figure out how to do this. We can use this write line to write a line of text. We can format it. We can use read line to read something. I'm ignoring whatever's been read here. We also have different types called reference types. So we can run this. Okay, so I have demos here. So I'll just go into demos. I can run this. And it gives me the size of bytes associated with each of these things. Okay, so you can look and play and work with these, and it's just fairly straightforward. So in C#, and in fact C++, we also have reference types. Okay, so reference types, they don't contain any data in a variable, but they're a reference, which is a memory reference or some location to a variable. Sometimes we used to call it in C#, they're like pointers. Okay, yeah. You probably don't have these, obviously, in some of the other languages that you would have used, that you use. Okay, but objects and strings and dynamics are some kinds of reference variables. So object is an alias for system.object. And it can be assigned a literal value of null. Okay. In terms of an object, we have something called boxing. Now you've done casting before. Have you come across casting when you've been looking at languages? Yeah. Casting, changing from one type to another type at the time to make it useful. Sometimes it's downgrading, rarely upgrading, but it may be. Yeah. And sometimes you will see this kind of stuff. Okay. So boxing is converting a value type into an object. Value types would be like ints and so forth. Yeah. And the reverse is called unboxing. Okay. That means converting an object to a value type. With strings, okay, we use the equality operators, double equal and not equal. They're defined to compare the values of the string objects, not the references. Can you see the difference in that? So if you have a string that points to, string is a reference type, and it points to a value somewhere in memory, and you want to compare two strings, you're not actually seeing the two strings at the same memory address, same reference. You're actually converting, because it makes more sense when dealing with strings, to see are the actual values that they have the same. So it's more intuitive to do it this way. Strings are immutable. Okay? That means that they cannot be changed after they've been created. Okay? So what's happening with this one here? String B is assigned a value that's not equal to. Okay, so we don't want people to be saying equals. String B equals hello. It doesn't. Okay, equals is this one. This single is called assignment. I talked to you about languages and the use of language in coding. String B is assigned the value hello. B, we use a concatenation operator here, okay, is now assigned the value of its previous one plus world. So what's going on here? How many strings are created? How many strings have been created here? Given that they're immutable. one string. So we create the first string, and then we have this string. Yeah, 3, 1, 2, 3. Okay. So this is the simple stuff, okay, really, with new language. I mean, if you're asked this in an interview, you may be asked to explain your thinking. I mean, it's like essentially it's first year stuff, okay? What's really happening when you're told that a string is immutable? Let's look at strings. So we might want to actually look at various comparisons here. So let's look at this. So we have a string here that is assigned the value of hello, and a string B is assigned the value of H. Okay. So now we want to append the contents. We want to now change B, so it now is B plus LO. So now if we want to start comparing the strings, we can see does A equal B? The trick, of course, is you could be asked in an interview, what's the result going to be? You know, and the trick is that if you don't know, try to work your way through these things. This is your answer doesn't matter here, okay? Right? I mean, I'm not trying to trick you or something. It's a new course. What I'm trying to do is to get you to think about the code that you write. I'm trying to get you to really think about what's actually happening under the hood. Okay? Because that matters, you know? It matters as third years. It matters when you go for technical interviews. Did you really understand what's happening? And they often ask the simple stuff. They don't ask you to write a big program to do something. They want to know, do you really know what's happening here? Okay? This is an interesting one because here we're looking at comparing the references, A and B. So you can actually compare the references types of two identifiers. Let's run it and see. Okay, so the two are true, but these are, you can see that it's true. So the two strings are the same because they're actually comparing the values, but if you look at comparing the references are different. Okay. And so what's happening is that you're creating a string, the initial string, you're creating a string that you don't actually have access to, apart from the moment it's created. Okay, so that's literal. Then you're creating another string that does this. Okay. So it's good fun, you know. And as I say, you know, it's a simple line of code, but you need to know what's really happening. And I want you to get into thinking about what's really happening when I write a line of code. Okay? Because if you can't understand the simple stuff, or don't think about the simple stuff, it becomes much more difficult to think about the harder stuff. Okay? And this is just about discipline and thinking about coding. Okay, we talked about boxing. Okay, I mentioned boxing somewhere on that slide. I hope I did. So with boxing then, again, it refers to reference types. So here we have this object, O, and here we have an int, which is I. Okay. So I'm after giving you, I told you what it does, okay, already. But if we look at this int I, and then we say object is assigned the value of I, object O is assigned the value of I, it copies the value of I into object O. Now if we change the value of I, you see again, this could be the kind of thing that you could be asked in an interview. What happens to O? Stays the same, yeah? Good, right? It stays the same because it doesn't affect the value stored in O. Because it's about copying at that point in time when we use the assignment operator, it copies the value in. Okay? Right? That's something to bear in mind. You know, you may not have to think about these kind of things before when you're dealing with languages that manage all that kind of stuff for you without thinking. Okay? But you have to do some of this work. So the value type is different to the object type. That's for boxing. Let's have a quick peek at this. And we can see down here, this is something useful to know. Sometimes It's the simple stuff like this that causes you nightmares when trying to debug programs. Okay? Unless you use the debugger, which will, I don't know, be pretty obvious straight away what's going on. But understanding helps. We talked about unboxing, so I have a little demo for unboxing for you as well. So now we'll try to do some unboxing. Okay, now you've done Java, you've all done try and catch with Java, yeah? It should be like in there every time you want to do something that deals with data that could not be or might not be the kind of data you expect it to be. Okay, always be using your tries and catches for exception handling. This is the way we do good programming. Okay. Want to see that? It's very similar to your Java model. Okay, so you try something, knowing that something could go wrong. Okay, depending. You know what they say about programming. You know why I rarely ask students to write software that has a user interface that takes input from the users? Because you've got to spend so much time trying to handle all those inputs that it takes away from the time I want you to actually spend on the problem, which is more interesting. Okay? And I have this basic rule that you can't make a program foolproof because fools are so ingenious. Okay? You don't know what they're going to do. Okay? And I love nothing better when the student says, oh, well, do you want to try my program? And I go, sure, and I type in rubbish into their program for inputter's input just to see what happens. And most of the time it breaks, because, my goal in life is to break other people's programs. Every chance I get, I try to break a program, I remember the first time that Specsavers introduced this small iPad thing for testing your hearing. Did you ever see those? Okay, so this pharmacist had these in the shops, So they went in and I said, oh, I'll do this, please. And, within minutes, I had a list of all of the people that had actually used the app, okay? And the data, all of their data was visible on the screen and said, I think you might be in breach of your GDPR here, by making this privately available, the data to me. Now, of course, it's a fine balance, I just wanted to check to see was my data available. But legally, you could be in a situation where you could be called a hacker, and that's not good really because you can get in trouble then. Okay, but nothing wrong with trying to break programs. And the lesson for you, of course, is always protect yourself. Okay, use try catch. So what's this one trying to do? Let me have a look. Okay, so I'm going to try to unbox and cast essentially to a short. Okay. And you'll notice in some of the demos that I give, and again, the whole point of this is to talk you through how we do some stuff and how you practice and play, okay? This is all about play. I cannot underestimate the power of play. Get things wrong and just try something new, fix it. It's play. This is a controlled environment, You're not trying to land a rocket on an asteroid, okay? You're just trying to learn some stuff and make mistakes and see what the error is. And when you learn the error, you come across it in your real programming and say, I've done this before, I know how to fix it. Okay? Play is so important, So we run this, and we have this invalid cast exception, which is one we're trying to catch and say that there was an incorrect unboxing error. So let's see what happens when we try to cast this to a short, okay? Run this. Okay, so we got an error here. Okay, and we kind of expected that because it was unable to cast a system or object of type 32 to an object of type 16. Yeah? Do you know what that means? Can you actually read this error and know what this means? Does anybody not know what it means? I mean, it's fine if you don't, just I can explain further. It has to do with the potential issues around the size of the number that you can contain in an int 32 could be bigger than the one that you can actually store in 16 bits of data. Yeah? And even though the number is small, it was 400 and something, there's always the potential that it couldn't be. Okay? And so that's why it's giving this error, yeah? So boxing and unboxing. Going one way, it's not like in maths, you remember we did these one-to-one and onto functions, yeah? Yeah, it's not like this, okay? So let's change it. And this is why I have these commented out sections here, okay, so that you can actually do the changing and play yourself, okay? So let's do this. Fix it, okay, get away. Let's run it here. Okay, so our unboxing was fine, okay, because there was no problem doing the conversions back again. All right? So you'll see a lot of this kind of stuff when I in the demos, that as we work through the course, there will be whole sections of code where will be commented or uncommented. Deliberately, I usually start the code with the one that will give you the error, okay, so that you have to actually try to fix it. That's kind of deliberate, you know, but if I made a mistake and I didn't give you one that had an error, change it so that you get the error and that you get familiar with it, you know. Nothing wrong with look, there's nothing wrong with having errors in your code. If it's a learning exercise, you know, you have to fix it. Have any of you ever heard of this personal software process? Did you ever come across this personal software process? So my issue to you, right, if I was interviewing you, and as I said, many of you will be coming for interviews soon, or are undergoing them now, if I ask you, how do you write code? How many lines of code in C# or Java can you write without making an error? Yeah. So what's your coding rate, you know, without errors? Is it 20 lines? Is it 100 lines? Is it 4 lines? You know? And how do you tell, or how do you know at what point when you've got an error? Okay? Can you see that if I'm employing you to code and design code and develop code, if you're going to spend every 20 lines compiling and running and checking to see if there's an error, then that slows you down, yeah? Considerably. So I want you writing hundreds of lines of code and then doing some time to check. And I also want you to be able to look at the code and see, oh, is there an error there? That's why sometimes using something like VS Code or something that, you know, at least gives you some syntactical issues around this. Okay? It gives you some syntax highlighting to give you some indication of where the errors are. Okay? Errors are a bane of your life. Okay? But, you know, that's the way it works. You know, they're a reality as well. Okay? Try to improve the number of lines of code you can write error-free. Okay? And one of the best ways to do this is to reuse code that you know works. And this is why we have patterns. If we have patterns, we know how the patterns work. Okay? And then it will make life a whole lot easier for you. Okay. Okay, so we were able to fix this. So let's have a quick look at their reference types. So there are other reference types that you're going to come across in C#. For example, there's a dynamic type and a delegate type, and we see these as we work through the module. Microsoft has a great article on reference types, and you can click through to that article here, and it's really worth checking out that documentation online here. Verbatim string literals start with an ampersand, sorry, not ampersand, an at symbol, sorry, and they're enclosed in double quotation marks. And the nice thing about these verbatim strings is that the escape sequences are not processed. Makes them easy to write. So you got a fully qualified file names, you could use something like this without ever having to do something like this. So backslashes would need to be escaped with backslash, and we want verbatim strings. So it's much nicer to have that. You might want this woot, cry the thief, and then you don't have to worry about, because you know we have these quotes in here as well. Okay? So it's always nice to be able to have those. And you can also, which is very useful for you as well, to use the double bracket operator to actually pick out individual characters of a string, which is something people don't always remember. It's useful. You know, you don't have to select them using regular expressions or iteration over that. So it's kind of nice to be able to do that sort of stuff. Okay. Okay, so that's just a tour of the basic stuff, and really the purpose of it was to tell you all the other stuff, not just to show you those. Okay. Any questions before we move on to iteration, conditioning, and decision making? Okay, so C# provides the usual decision-making statements used in programming. You have if, else, and switch statements. It also includes a hook operator. That's my favorite expression ever. Okay, and it can be used for decision-making. Okay, I love the hook operator because it evaluates, makes a decision, and returns it's an expression, you know, and it works like this. So you have an expression, hook, expression 2, expression 3. So expression 1 and expression 2 and expression 3 are expressions. Evaluate xp1. If xp1 is true, then xp2 is evaluated and becomes the value of the expression. And if xp1 is false, then xp3 is true and it becomes the value. Okay? I love this stuff. Okay? The only downside of it is that people don't understand how it works, and they use it, and then you get lots of errors. And the problem with errors is that they slow you down. Okay? And you spend time working on them, and that's not. So often in software engineering, so it's a good coding because it means it reduces the lines of code. But the problem sometimes with reducing the lines of code is it becomes more difficult to read. And it becomes obfuscated. You've heard that phrase, yeah? The code becomes obfuscated, difficult to read. Difficult to figure out just by looking what's actually going on. And therefore, it becomes difficult to debug when things go wrong. It might be difficult to give to a team member. Okay? So while this is my favorite expression and I use it everywhere, the code I use is usually just for me. I wouldn't be recommending using this if I was in a team. Yeah? Unless you're like loads of people like you, and it isn't often the case. Okay? I used to do this stuff for fun. You heard a programming language called Perl? Yeah? No? Perl is a command line programming language that used to be around before Python became very popular. Okay? And it's really kind of like hardcore sysadmin language, and you know, it's very difficult to read, notoriously difficult to read. But every year, they used to have a world programming contest to see, could you make a program even more difficult to read using obfuscation? Okay, and it's useful. It's also useful. Obfuscation is also useful when you're trying to distribute, say, JavaScript code. You don't want people to steal your code and be able to understand it easily. So there's places when that's good, but in generally, from software engineering terms, it's not good. So think about this when you write your code. So it might be better just to use an if condition. And you might have an if or an if else. And you know all about that stuff, but there's usually, you know, it's straightforward. I'm sure you know how to do all this stuff already. If we look at decision making, and I mentioned at the beginning of this class that I'm really interested in enumerations. Okay? So I'm interested in how we might actually do something like this. So here's a nice program. And I'm going to use it with the switch statement in C#. And the reason I'm doing this is because you'll need it for your assignment. Somebody asked about the assignment. Generally, we have somebody who wants to have inputs, commands. And we might set up an enumeration to represent the command so we can identify which command we're using. Okay? And so a lot of the time, we take the data and then we evaluate those data. Okay? So I can tell you now that at the end of the year in your coding exam, you will be asked to write a command line program that takes commands. Okay? So you'll need to know how to take in data, decide what the command is, and then figure out what to do with that command. And that hinges on switch. Easier than a whole bunch of if statements. There's a really nice example using enumeration to demonstrate the statement here. Can you see where the enumeration is? At the very top. Okay, at the very top, I have this public enumeration called color. Red, green, and blue. I'm not creating variables or constants with a particular type and a number and assigning them some value and hope that they won't change or something. And you know, I'm doing constant in front of it, and you know, and I'm making sure I'm sticking some other keyword in front to make sure that it can't be changed and all this kind of stuff, right? None of that. Like const, int. I'm actually just saying I'm interested in working with colors, and the colors I'm interested in are red, green, and blue. That's it. You know, it's nice to have that. I don't have to worry about anything beyond that. It's an enumeration. You'll see that red is less than green, and green is less than blue, by the way. Okay? If you want to start doing some mathematics on these kind of things, it's an ordering in some respects. You can think about the ordering, or is there an ordering? You can play with it and see. I mentioned play earlier. Do some play. So the enumeration type is a value type, and it's defined by a set of name constants of the underlying integral numeric type. Okay? So we have our statement here. And so what I'm doing here is I'm actually randomly generating the next number in the enumeration, because I said to you it has an order, right? So we know that when we look at something 1, 2, 3, 4, the whole point of enumeration is we know what comes next. We know where it starts, know where it finishes, and so forth. So I can use this random function to generate a random number. Then I'm actually unboxing, casting, yeah, to a color. And I'm creating a variable here of type color. You might sometimes think of these as like objects, or when you're looking at classes and so forth and all this kind of stuff, yeah. But it's like they're objects in a way, reference types. So they behave in much the same way as your objects would do. And so I'm able to do some manipulation with this. In fact, guys, I can do all this kind of stuff with Java as well, by the way. Okay, I can do it with JavaScript. I can do it with Python. I can do any of your languages that you know and love, or know and hate. Okay, so now I'm switching the color and telling me that the color is red, the color is green, the color is blue, or the color is unknown, unless it's something I don't know. Okay, I would hope not to get this. Okay. Yeah. So it's nice to be able to do this. Now we might sometimes want to be able to have something that allows us to switch from the string red or the string green or string blue to the color enumerative type. Yeah? Any questions? I've got some nice examples. If you click through here on these links, it'll help with those as well. Yes, Nick?
Might be a misunderstanding of the random function.
Yeah?
It
So sorry, I meant to, yeah, it should. What's happening here is it's going to give me, it should give me an error, okay? Unless I'm saying if I, this is the error, okay? Because there's only 3, so it should be 0, 1, and 2. And I'm telling it to pick something that's a bit higher. So yeah, it should give an error, okay? We don't want it to if we're dealing with things properly, but giving it away now, you know? But yeah, there is an error. There is an error here when we said that the color is unknown. But we don't know it. We don't know it because we've tried to convert or cast from a number that we don't know, a numerative type from an integer to the enumeration. Okay. And how are we doing for time? Yeah, we have 5 minutes. So I won't do the example. You can play with this yourself. Okay, and iteration again. We have all the normal looping stuff: while conditions, do while conditions, fors. And it's useful to have all those. I have a link to the examples if you want to see how to do those. And there's a couple of them here. And you'll notice that we also have this as for each. And I want you to know that for each is really useful. Have you used this in other languages? You've used this in JavaScript, right? Yeah. And you'll see it elsewhere. For each is useful. You'll notice here that I've created a list of integers, a list type. And if you notice at the top of the program, I'm talking about collections for generics. You did a course in last year in CS2 something or other, which was on data structures and algorithms, yeah? And you know about how to use and create lists and do all that stuff yourself. I don't need you to do any of that. I just need you to use the library that comes with C#. Okay, and it's the collections, the generic collections, and I'm now creating a list of integers here, and then I can do an iteration over all that list. I want you to write code from scratch. I want you to reuse code and build from there. You know, I know you all know how to write lists. Linked lists are my favorite data structure ever, right? Doubly circular linked lists are even better, right? But so you want to have a look at that, and you know how to use for each. You'll need to know how to do this. Okay, this is the core stuff. And finally, we can actually see that how to make app structures. I've given an example in the demos for the full app here, but we can also work with creating objects, classes and objects here as well. Okay, it's an object-oriented application, and we'll do more about this next time, and we'll have a look. Okay, so this assignment is about working with tables and converting between tables. Okay, it's about a command line interface, because I don't want you writing code just yet that has a user interface. So you need to do some conversion switches. Okay, if you do some searching for command line processing with C# in Google, you'll see that it provides you with an external library and so forth, and shows you how you can actually do something with this. Maybe do I explicitly say not to use an external library for this? No. If I tell you not to use something, if I generally want you to write something from scratch, I usually tell you to do this. Okay. But generally, this should be fine. So these are the commands. So you need to be able to parse the input. Okay. You did this with Java as well, right? Okay, so parse those command line variables, and then you do a switch on them to be able to see the switch, and that's the basics. So the first step you should do in your program is to start looking at handling this. How do I write a program that allows me to be able to capture the command line contents, and that's available, right? You just Google that and it's there. Microsoft provides you with an example of how to do this, and then you have a switch, and you just, for each function or each section, you create a function for this on each switch statement, and print out you selected verbose, you selected file, you selected this. Once that's done, you start working through each of the various options to be able to read a file. How do I read a file? Google how to read a file with C#, or it'll be in my notes, okay, online. You've got a couple of weeks to do this, so there's time anyway, okay? And how to read a file. Once you have the file read, how do I print something? And then there's the conversions, of course. The conversions, I would say, the best option would be to have an internal representation for the table and convert whatever comes into that internal representation first, and then you can write functions to be able to export to another format. It's very straightforward. There's a question, we'll be quick.
Can we use external libraries to parse the input files?
I think I wanted you to do this myself. Does it tell you? Tell you in there? You must provide an object, or you must comment your code. You must provide C# command line arguments. There are solutions. You must not reuse the code from these. Cite your references. Okay. Table generator. Yeah. I think it should be okay, as long as you're not like cheating and taking a solution. Okay. Another question?
Could you touch on what you want from the verbose option?
Verbose option usually will tell you the steps that are happening, generally. So verbose is about verbosity, and it's just generally about trying to fill in the gaps and tell you some extra steps. Now I'm reading the file. A lot of the time, this is where you might get the errors or something. Okay, so try and catch something, try get it, convert it, and then try export it. So that will be fine. Okay. Any other questions before we stop? Thanks for coming, everybody. See you next week. See you in the labs. Okay. Thank you.